Geoheritage Expert Group webinar from the EuroGeoSurveys. The title of our webinar is Safeguarding Geoheritage Best Practices from Protected Areas. And before we begin, I would just like to give you a little bit of background to the Geoheritage Expert Group. My name is Kirstin Lemon and I am chair of the group, and we are joined by the deputy chairs, Claire Glanville from Geological Survey Ireland and Enrique Díaz from IGME in the Spanish Geological Survey. So just a few details before we begin. We've already specified that we will be recording the webinar, but can I also ask that everyone mutes their microphone? Can I also ask that if you want to ask a question in the Q&A session, that you raise your hand before doing so? And throughout the webinar, please feel free to add questions into the chat, and we can ask all of those questions at the end. So the Geoheritage Expert Group. The mission and vision is something that I thought would be good to share with everybody on the webinar, with our mission being to advance the conservation and sustainable management of Europe's geological heritage by collaborating with national and regional partners to provide essential knowledge and expertise. Our vision, however, is to provide a framework to deliver services to society through geoconservation, ensuring long-term management of Europe's geoheritage. And this webinar is one of the ways in which we're helping to deliver our mission and achieve our vision. The agenda today will be as seen on the screen, and I know that the times given may be different depending on where you are, but just let you know that I'm going to do the quick introduction, then I'm going to hand over to Enrique, who will be giving a talk entitled Management of Geoheritage in Protected Areas. Then I will give a talk on UNESCO Global Geoparks and protected areas with examples from the UK. And then we'll finish with Matevž Novak talking about protected areas and geoconservation in Slovenia. And then we'll have 20 minutes at the end for a question and answer session. So before I pass over to our first speaker, I thought it would be timely just to give a quick introduction to all of our speakers. So apologise to the speakers as I have taken these ones off the internet as well. The one of me is from a good long time ago, so that's a good thing in my opinion. So just to introduce myself first of all, so I am the Science Programme Manager for the British Geological Survey in Northern Ireland. My role is in looking at best practice in safeguarding geoheritage, supporting knowledge exchange, geoscience communication and outreach, and promoting the integration of geoscience into wider environmental and community initiatives. My background is primarily in UNESCO Global Geoparks, and I'm one of 12 members of the Geoparks Council and also a senior evaluator for the UNESCO Global Geoparks. I am currently the chair of the Irish Geoparks Network and a former chair of the UK Committee for UNESCO Global Geoparks. I'm also the national contact point for the IUCN 100 geological heritage sites, and I've been a member of this committee since 2021, having only taken over as chair since 2025. Our next speaker is Enrique Díaz, who I am sure most of you on the call will probably know. Enrique is a senior scientist at the Spanish National Research Council, and he's been there since 1998. Since 2004, Enrique has worked primarily on geoconservation projects that includes inventories, legislation, management, training, consultation, and public outreach. Enrique's research includes more than 200 scientific publications and more than 30 popular science publications. And he's worked for over 30 years in positions related to geoconservation, the latest including being the founding member and the chair of the EuroGeoSurveys Geoheritage Expert Group. Our final speaker is Matevž Novak, who is a senior scientist at the Geological Survey of Slovenia, where he's been since 2000. His fields of expertise include Paleozoic biostratigraphy, paleontology, sedimentology, geological mapping, and geological natural heritage. Matevž is president of the Slovenian National Committee for International Geoscience and Geoparks Programme and he's a corresponding member of the IUGS Subcommission on Carboniferous Stratigraphy and on Heritage Stones. He's also a member of not only the Geoheritage Expert Group, but also of the Geological Mapping and Modelling Group of the EuroGeoSurveys. And he's involved in not only geoheritage, but also education and in the popularisation of geological science. So I think the speakers we've got today, we should get a good breadth of information and knowledge on the topic. And with that in mind, I'm going to just hand over to Enrique, who'll be delivering our first talk. So over to you, Enrique.
Okay, thank you. Let me share the presentation then. You can see it, okay?
Yep, that's good.
Okay, so we have 20 minutes. I have 20 slides. Hopefully I will manage with this. I'm going to give a brief overview about the management of geoheritage in protected areas. For some, this may be already known, but I know from my experience in Spain among geologists that many of us have not been taught about the peculiarities of protected areas. And so I have tried to summarize some of the main issues. I always want to begin with some slides about basic concepts. Like we'll talk about the 5 geos, these words that have started being used in the last few decades, 2 or 3 decades, and then some conflicts and confusion that arises from that. So it is clear to what I am referring to, the difference between natural and cultural heritage, examples of geological heritage in protected areas. That's important. So this is not going to be so much about beautiful places. We will see them, but it's not only that. I will talk about the value and relevance of sites. What does it mean? And then the relevance, of course, of geoheritage inventories for protected areas. It is key to know what those areas have. Okay, so there's these 5 recent geoterms or words that begin with geo in the last few decades. I was mentioning geodiversity. I want to make it clear from the very beginning that when at least our team in the Geological Survey of Spain, when we talk about geodiversity, we only refer to the parameter. So geodiversity can be high or low. It's a parameter that measures the variety of certain geological elements. Geological elements are natural abiotic elements and also the processes in a specific area. There's many processes and many elements in an area. And what's key about geodiversity is that it underpins biodiversity. So usually when you have high geodiversity, you would expect high biodiversity. Another word is geoheritage, which is a selection. Some of those geological elements, not all of them, only some of them, that are selected for their interest, their value, usually with respect to their potential use. And this is what is focused by geoconservation. That is where geoconservation should be oriented. That selection of geological element that is geoheritage. Geoconservation then are the strategies and actions that are taken towards the conservation of what we care about, which is the geoheritage, and also geodiversity, the parameter, because if it's high, it will be conditioning the biodiversity, as I was mentioning. Geotourism is a type of tourism that is oriented towards the geological elements and processes, and geoparks are a type of management strategy that uses geoconservation and geotourism for local socioeconomic development. Of course, you can always expand regarding any of these meanings. I will just Which are the benefits of geodiversity that I was mentioning? One is that it underpins, it controls, it conditions species, habitats, and ecosystems. So it is conditioning also the biodiversity, and also determines their resilience, which means the resilience of biodiversity. Normally, what we care is about the biodiversity. That's why we also want to make sure that the geodiversity may be preserved as a high parameter, because it will lead to higher biodiversity. What are some of the weaknesses that we have with geological elements compared with biological elements? One of the key factors is that geological elements are non-renewable, most of them. Water is in a cycle that is more or less in the human scale. But most of other geological elements, like Precambrian rocks, if we lose them, if we destroy them, there's no possibility to get them back. So that's the key factor for preserving some selected sites, which is the geoheritage. Another factor is that geological elements are not resilient. So even if there's a risk of losing them after a crisis, they will not recover. Whereas when we have habitats or species, we may try to recover. We may have a plan to recover populations, but with geological elements, that's absolutely impossible. And then it's not always impossible because we have intrinsic vulnerability, which means that with active processes, the same process that destroys features, geological features, may be also creating them. And there's some examples of that. We can talk about it, but knowing if a geological element, if some specific geoheritage site is involved in active processes, we may use this intrinsic vulnerability as a way of kind of renewing the different elements, and it's a part that has to be very much considered in the management. This slide is referring in general to all heritage, any type of heritage. It's the set of elements to which we assign value. So it's elements with value. That means that elements that have little or no value, we will not consider them heritage. And another important factor here is that, which you will see down there in this little formula, is that the type of element establishes the type of heritage. This is very important because I have seen many people saying that it's the type of value which determines the type of heritage. No, 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 no. The type of element, if the element is tangible and it is considered valuable, then we would have tangible heritage. If it's movable, like in the geological site, I mean in the geological like fossils or minerals that we take into the museums, then it is movable heritage and so on. So the type of element determines the type of heritage. This is what is seen here in this little formula. And another important thing here is that the value is always subjective. So it is conditioned by cultural factors, which means that we need to evaluate periodically and we need to be careful with the evaluation of the value, because that's what's going to determine if it is geoheritage or not geoheritage. If it is any type of heritage, like for example, this trilobite here, it's not the same if it is very common or if it is very rare, or the Gioconda or anything that the specialist will tell us if it is actually very valuable or not. Okay, so the conclusion, heritage are elements with value, and the type of element determines the type of value. And that's what you can see down there. So if we have natural elements with value, that would be natural heritage. If we have geological elements with value, those would be geological heritage. And this is another crucial concept, which is the difference between what is natural and what is cultural, because this is what many administrations divide the management of cultural heritage and natural heritage. Even the United Nations through UNESCO, when there's this World Heritage Convention, separates cultural heritage, cultural World Heritage sites, natural World Heritage sites, and then there's also mixed, where you have both of them. And what is the difference? The main difference is the element a result of intentional human activity. If it is, then it's cultural. If it is not a result of intentional human activity, it's natural, directly, okay? And then when we are talking about geological heritage, you can see here that is a type of natural which is abiotic, and then amongst those, it would be geological. Another important concept when we talk about protected areas is that in the last 5-10 years or so, maybe a little bit more, there's this separation of considering protected and conserved areas. What is the difference? You can see summarize them here. Protected natural areas or natural protected areas are these legally designated spaces with nature conservation as primary objective, okay? The main objective, and also it is done through legally binding conservation. You can see at the other end, on the right end, type of management of protected areas, strict management with clear, legally binding conservation objectives, which is not the case necessarily for conserved natural areas. This I have put OECMs, means other effective conservation measures, as you can see below there, which are areas outside of the protected areas. Actually, even the protected areas may be within the conserved areas. So the conserved areas include both the OECMs and the protected areas, and they have positive long-term in situ conservation of nature, which means it's a way of preserving nature, but not necessarily through a legally binding instrument. Okay, so not legally designated specifically for the nature conservation. Okay, some examples of what we know as protected areas: national parks, natural reserves, natural monuments. And then, for example, conserved areas that are protected not by legal instruments, but that have a type of management that may allow for the preservation of nature. For example, watersheds, drinking water supplies, indigenous territories, sacred sites, military lands. These are some examples. Not always. They are the primary objective is nature conservation, but sometimes a result is that nature is conserved. Okay. Then during the concept of natural protected areas also has been evolving through time in the last decades. There was an idea, you can see here on this is from a work, from 12 years ago. You can see there the site. I can send whoever wants. The Iceland approach. So the protected areas were defined by just a polygon with an area for a buffer area. Then there was the concept of networks as protected area networks. Then the landscape as a protected area based on the landscapes. And then lately they are also including a socio-ecological approach, especially for the categories 5 and 6 that I will mention later of the IUCN. See here that you can see this mentioning this IUCN in the legend, category 1, category 2, category 3, 4, 5, and 6. So the 5 and 6 are more lately being used. And you can see here in the evolution of the concept of protected area, you can see that the marine areas have started mostly in the 70s. The continental terrestrial protected areas started in the late 19th century, but mostly in the beginning of the 20th century, and now they are increasing quite a lot. See, the total area that is protected in the world now is over 25 million square kilometers. And also for the mean surface area, if you can see, originally in the beginning of the 20th century, the size of the protected areas was very large, and it has been gradually reduced. The proposal of protected areas, usually they are now more smaller, and as a result also of the conurban, the growth of the cities and of the urban areas. So they are limited to smaller places. I was mentioning the IUCN protected area categories. You can see them here, 1, 2, 3, 4, 5, 6. And they from very, very strict protection. You can see here the list on the left and like a visual mental map of where they fit. When they are the most natural are 1A, 1B, 2, and 3. And then with more human influence are the 4, 5, and 6. And then the line that you see here, the diagonal line in this chart, shows the degree of environmental modification. So 1 and 2 and 3 are the least modified, and when you go higher for 4 and 5 are with the higher human influence. Actually, some of these protected areas of categories 4, 5, and 6, they include the preservation of the sustainable human use of the territory. And that's very crucial because this type of categories, which are the official type of management recognized by the International Union for the Conservation of Nature, these are the ones that all the protected areas that are legally, so this is the protected areas in any country, must follow specific requirements and specific strategies and protection plans and actions depending on the category that they have chosen for the preservation. Some of them don't allow even public, like 1A, no? So, but then number 2, which is the national parks, the ecosystem conservation, includes public use, but only when it is strictly controlled and sustainable. So I will show you some examples of this geological heritage in protected and conserved areas. Most of them are from Spain, as you might imagine. The typical geological heritage sites, for example, are unique geomorphological landscape features, like these ones, the Teide National Park, which is also UNESCO World Heritage. Many times they are overlap the different figures. Torcal de Antequera, that's in the south of Spain. These are geological elements that are included in protected areas. And depending on the type of protected area, the Teide is National Park, which is category 2 of IUCN. Torcal de Antequera is category 4, natural protected area, and it's also UNESCO World Heritage Site. I must say that UNESCO World Heritage Site is not a legal protected area. The UNESCO requires that the country that has proposed this, once it is or before it is accepted, the area must be protected under whatever legal instrument the country has. Normally, like you see in these cases, it will be national park or a natural protected area and so on. This is another case. This is a global geopark, the Basque Coast, UNESCO Global Geopark. It is also a special conservation area of the Natura 2000. This is the European network of protected areas. And it is also what's called a natural landscape, protected natural landscape. So it is category 5 of the in the Basque Country, Deba Zumaya. So you see, there's different management strategies, and in this case, it is not most, but it is one of the key elements of this area with these different legal instruments and including the UNESCO Global Geopark, which is not itself as Kirstin will mention later. It is not a protected area, but all these legal instruments have different distribution, and they will have different strategies for the conservation of nature, in this case, of the geological elements. Several ones that are also very much well known, for example, the Grand Canyon National Park is also UNESCO World Heritage Site, and the Giant's Causeway, which is UNESCO World Heritage Site. It is a special scientific interest area, a special area of conservation, natural nature reserve, and the Causeway Coast area of outstanding natural beauty. So many different overlapping legal instruments, some of them maybe just management, different types of management to allow for the preservation and use, sustainable use, of course, of the geological heritage in this case. So all this should have proper knowledge from the managers of what is and what is not recommended for the different geological elements of interest, the geological heritage. Another, for example, sites that are geological heritage, the first sites. In this case, the term caldera was originally defined here in the Caldera de Taburiente in the Canary Islands. And this is also a national park. It is also a special conservation area of the European Natura 2000 network. And it is also a biosphere reserve, which is not a legal instrument for protection, but it is a strategy for the management, and it also includes, they have done in many biosphere reserves, their own inventory of geological heritage. And geological heritage can be properly managed also, like we were saying, in conserved areas, like biosphere reserves or geoparks, even if not the whole territory is a protected area. only for example, in the case of geoparks, we know that it will be only the specific elements that are of international relevance that are required to be geoheritage. This is protected. An example that we frequently use, it's a natural monument. It's part of the slope of a hill in the province of Guadalajara, and it was very difficult to convince politicians that this is of international relevance and that this should be protected, and that the best figure was the natural monument. Natural monument is a legal protected type of protected area, and it's because it has been recognized, established by the International Commission on Stratigraphy of the International Union for Geological Sciences, that this is very relevant and should be protected. And so it went as such, and now it is protected, and thus it was allowed to be the GSSP. Here I just want to mention it's a visual graph that we frequently use to show the size of geoheritage areas, and also the level of significance, and how you can have elements that are big and small, and some that are not considered geoheritage, and some that may be considered international, national, or so geoheritage. So it's different levels of relevance, of significance, depending on the administration that we have for the protection. Okay. What is important for the natural protected areas? That they know what they have, which means you need to have a geoheritage inventory. Geoheritage is part of natural heritage and maybe of high national or international or global relevance. So the manager of the natural protected area, like any, for example, restaurant manager, they need to know what is available. They need reliable personnel with knowledge and experience. They need quality kitchenware, which means fine instruments to work with. They need quality ingredients, which is to know what do they have, where is it, how much is available, what is it good for. So all these things are part of the inventories that managers of protected areas need to have. And also this proper management requires to know that these elements are available. This is only done with the inventory. The type of elements, which is the typology, the administrative level of significance that I just showed, the relevance of this value, the potential use, what is it good for, the type of values for science, for education, for tourism, the vulnerability. So what type of care should we dedicate to what funds, personnel, and also depending on how vulnerable, how susceptible to degradation, as we say, could it be affected by human threats, natural threats, and so on. So this has to be included in the sustainable use and management of geological heritage in protected areas. The scale of the inventory may be different levels, and according to the different levels, then there's different options. For example, UNESCO Global Geoparks and UNESCO Biosphere Reserves are of a regional scale. We have also national inventories that are needed for nature conservancy to decide what areas have this potential to be protected territories for the natural heritage, which is the geological heritage, and so on. To finish with, we usually include this type of 4 pieces that need to be worked with regard to geoconservation. You need to know what you have. That's the inventories. Identify, locate, classify, and map all the heritage that we have in the area. To do the strategic planning, policies, monitoring, and this has to come with legislation if it is a protected area, or with proper management and monitoring and enforcement in case of it is just a conserved area, not necessarily legally protected. For the conservation, we need all these aspects, impact prevention, preservation of the values and services, and so on. And for the public outreach, of course, the public needs to know why is this relevant. And for this, we usually do itineraries, guided tours, workshop, publications, and all these things included in the education. Use it for the local education at different levels, and so on. And then I will stop here, and we can have the questions at the end, I suppose. Thank you.
Thank you very much, Enrique. Just a reminder to everyone who is on the webinar, if you do have any questions, and you want to write them in the chat now, just in case you forget them, please do so, and we can get to them at the end. I don't think there's any there at the moment, so just a reminder if you do want to do that. Okay, so I'm going to take the floor again, and I think my talk follows on very nicely from Enrique's. So I'm going to try and share my screen. That's the wrong one. Okay. So hopefully everyone can see that okay?
Yes.
Yes.
Thank you. So I am going to focus on what Enrique has already hinted at, and it's specifically about UNESCO Global Geoparks and how the geological heritage within those is protected. My focus is going to be on the UK specifically, but a lot of the examples I'm going to give, I'm sure many of you on the webinar will be able to think of examples from your own countries as well. So just before I get into all of the details, I just want to give a quick focus on what UNESCO Global Geoparks are. So the definition from UNESCO is that UNESCO Global Geoparks are single, unified geographical areas where sites and landscapes of international geological significance are managed with the holistic concept of protection, education, and sustainable development. So the key phrase there is about the landscapes of international geological significance. So all of the UNESCO Global Geoparks must have that, and all of that must be managed, and that should include protection, education, and sustainable development. There are currently 221 UNESCO Global Geoparks in 51 countries around the world. The reason why I'm sharing that information is that the way in which the geological heritage within each of those geoparks is protected varies greatly all the way around the world, as you can probably imagine. The different approaches to geological heritage, the different legal mechanisms to geological heritage are very, very different. And I think it's just worth stating that before we begin. So whilst I am talking about geoparks in the UK, the European geoparks may have one approach, but that approach will be very, very different in Asia, and again different in South America, and again different in Africa. So it's just to sort of let people know that as we go along. With regards to legal protection of UNESCO Global Geoparks, as Enrique has already said, being a UNESCO Global Geopark actually offers no legal protection. However, the defining geological heritage sites within a geopark must be legally protected in advance of any application. So there has to be some mechanism in place to be able to do that. Some countries have come close to doing this by embedding geoparks into their legal frameworks or by creating national geopark systems. The examples I can give of doing that would be from China, which is where the picture on the right-hand side is from. This is from the GhEG UNESCO Global Geopark, where geoparks are created, first of all, by becoming national geoparks, which do have legal protection under Chinese legislation, but it's not for a UNESCO Global Geopark specifically, it's for a national geopark. In most countries, legal protection comes from pre-existing national or regional laws, and that's what I'm going to focus on for the majority of the rest of this presentation. So I'm going to focus on the UNESCO Global Geoparks in the UK, of which there are 10. So the map on the right-hand side will let you see where they all are. And even in a small country like the UK, there is still great variation, not only in our geological heritage, but also in how these geoparks are managed, and also how these geoparks are protected with regards to their geological heritage. The UK is made up of 4 separate regions, as many of you will know: England, Scotland, Wales, and Northern Ireland. And environmental protection is devolved to each of those regions. So the way they are approached quite often is slightly different. So what I'm going to do for the rest is to talk about the protection that is available for the geological heritage within these geoparks. Now, it's quite common that geological heritage that exists within the geoparks isn't protected, but what has to occur is that the geology that defines a geopark, the internationally important geology, has to be protected. And that can be done in two ways. It can be either done by what I call direct protection or by indirect protection. And what I mean by direct protection is national or local legislation that specifically mentions geology whenever it comes to putting that legislation in place. The first example I'm going to talk about is the sites or the areas of special scientific interest. These are a formal designation for protected land or water that does include geological or physiographical features. The purpose of an ASSI or an SSSI is to protect, manage and conserve special natural features, and this ensures they're not harmed by development or unsustainable land management. These have all been identified in the UK through the geological or the earth science conservation review process that was done a couple of decades ago, that has highlighted a number of sites that either deserve international or national or local recognition, and then many of those have gone on to be formally designated and therefore protected. There are currently 6,500 of these across the UK, but only 20% of these are primarily geological, and the remainder are primarily because of their biological interest, and that's something that we maybe need to think about trying to address. Just to give you a few case studies of how these fit into the UNESCO Global Geoparks in the UK. The first case study is the Kent's Cavern SSSI. This is an example of a Devonian limestone cave, which demonstrates classic processes of karst landscape development. It is given its status because it has helped scientists to understand quaternary environmental change because of the cave deposits that it contains, but also because it contains the earliest evidence of Homo sapiens in Northwest Europe, which has helped scientists understand early human migration into Europe. The one thing about ASSIs and SSSIs is that they are all about really protection, and there is no requirement for those sites to be made accessible. In fact, some of these sites are not accessible at all. However, the Kent's Cavern SSSI in the English Riviera Geopark is actually a public show cave. It's actually a privately owned public show cave as well. Since it opened in 1903, it's attracted about 10 million visitors. So it is a site that is very much active when it comes to accessibility and engagement. And it also is one of the sites where local schools come to visit, and it plays a pivotal role within the English Riviera Geopark. My second case study when it comes to SSSIs and ASSIs is Quilca Mountain, located in the Quilca Lakelands UNESCO Global Geopark. The mountain itself is 665 metres high, and it offers a complete representation of the Carboniferous Leitrim group, which, for those of you that aren't familiar, is from the late Brazilian to the Lemurian and contains an almost 8 million year sequence as you go from the bottom of the mountain to the top. It actually records a period of significant tectonic activity, basin subsidence and changing sea levels. So it's not only good for our geological heritage, it is also a really good place for education as well. Now, I mentioned earlier on about some of the ASSIs and SSSIs being designated purely for their geology or purely for their biology. There are also many that are designated because they have dual interests. And I think this will be a common theme to the rest of my presentation, is that quite often the geology, the geological heritage goes hand in hand with the biological heritage. And in this case, Quilca Mountain has got one of the most extensive areas of blanket bog in Northern Ireland, containing all of the associated habitats and species that go with that. The mountain itself is managed by the Geopark, and it's managed not only to maintain those designations, but also to provide recreational access, because it is one of the iconic walking routes in that part of Northern Ireland. But it's also then used for various school trips and various tours as well. One of the other mechanisms for direct protection is through the National Nature Reserves, or NNR designation. This protects areas of high value land or water that have been designated for their national importance in biodiversity, habitats, or geology. Similarly to the ASIs and SSIs, they are established under UK law and the devolved regions, but these are managed primarily to conserve wildlife and outdoor laboratories for research while offering opportunities for public enjoyment. And that is a key difference between the NNRs and the previous designation. There are approximately 300 of these across the UK, so much less, but they are worth noting simply because of their accessibility. So I'm going to provide another couple of examples in how these are managed and contained within UNESCO Global Geoparks. My first is the Wren's Nest Natural Nature Reserve in the Black Country UNESCO Global Geopark in England. This site was actually the very first National Nature Reserve designated for geology. There had been one prior to that based on their biology, but this one was for geology in 1956. It has been recognised as one of the world's most important geological or paleontological sites and contains exposures of the Silurian Wenlock Group limestones. It contains one of the most diverse and abundant fossil faunas in the UK, with over 600 species from 29 major animal groups, and is a type locality for 186 species, 63 of which are recorded nowhere else. I put a picture up on the right-hand side, which doesn't do this site justice because it is actually not it's not a large site, but it is big enough to be able to offer recreational opportunities for the surrounding area. It is actually surrounded by about 5,000 houses in the middle of a residential area. And the Black Country Geopark is quite unique in that it is completely urban. So to have a national nature reserve like this in the middle of an area that is so built up, and in many parts it is socioeconomically deprived. So this is a really valuable asset to the local area, not just scientifically, but also from access to the site itself. One of the other associated interests with the geological heritage is its contribution to the Industrial Revolution, because the limestones and many of the other rock types locally, including coal and ironstone, were what literally founded the Industrial Revolution in England. And the site itself has got many of the associated sites that go with that. My second case study for the National Nature Reserve is Knocken Crag in the Northwest Highlands UNESCO Global Geopark in Scotland. This site includes one of the clearest demonstrations of the Moyne thrust, and it was here that geologists were first able to explain how the thrust occurred, and it provided vital information into how geological science developed over time. The site itself, however, whilst offering really fantastic demonstrations of the Moyne thrust, is not just about giving access to the geology itself. It also provides walking routes and an unmanned visitor centre with fantastic interpretation that anybody can visit along the main routes that go through the Northwest Highlands Geopark. The picture you can see in front of you shows a sculpture that was done for the site that helps you interpret the landscape, and other sculptures on the site help you interpret the stratigraphy in artistic and creative ways, giving access to that geological heritage that is actually quite hard to understand. So it makes it accessible, not just physically, but also for those that want to understand the geology as well. I'm now going to move on to talk about indirect protection. And what I really mean by that is looking at designations, formal legal designations that actually don't offer direct protection for the geology and the geological heritage, but they do offer it for other aspects of the natural heritage, and by default then help us to look after the geoheritage as well. The first of these is the national landscapes. National landscapes are areas that have been recognised due to their high quality and distinctive scenery and national importance. They are protected to conserve nature, to aid biodiversity, to store carbon and offer public well-being. And of course, we all know that biodiversity and the geodiversity go hand in hand as part of nature. So we are then protecting our geoheritage as a result. There are 46 designated areas in England, Wales and Northern Ireland under this type of designation, and in Northern Ireland they are known as areas of outstanding natural beauty. I've put a map on the right hand side to show where the national landscapes are. There's some that are only proposed, but it'll give you an idea of the number that there are across the United Kingdom. Enrique has also already helped to explain the IUCN categories. So this is known as a Category 5 protected area. So it's not quite as strict as the other ones that I've mentioned, but by having this level of protection, it does mean that there's a requirement then to have a management plan for the wider area, and this is done in conjunction with local partnerships and teams. So the case study I'm going to give for this one is the North Pennines National Landscape, which shares a boundary with the North Pennines UNESCO Global Geopark. The area itself makes up 2,000 kilometres square of upland area in northern England, and the designation provides protection for the landscape and the components of natural beauty. It doesn't mention protection of geological sites per se, but of course we all know they make up the component of natural beauty. The projects that the National Landscape delivers, however, do provide indirect protection for geological sites. The example on the right-hand side, whilst it might not be quite as pretty as some of the other ones I've showed you, is a picture from a Calamanarian grassland restoration. Now, for those of you that aren't familiar with what that type of grassland is, it's a grassland that is made up of sparse and harsh species that thrive in soil contaminated with high levels of heavy metals, such as zinc, lead or copper. And the North Pennines' internationally important geological heritage is actually as a result of some of its lead mining history. It was at one point the largest lead zinc mining area in the UK. That area obviously is no longer working, but a lot of the legacy and the geological heritage is in association with that. I'll then move on then to talk about another method of indirect protection, and this time through national parks. And many of you will be familiar with national parks. And this is one of the most common ways that a lot of geoparks, especially in Europe, gain their protection. And again, Enrique has already alluded to that. So national parks in the UK exist to conserve landscapes and promote public enjoyment. They're legally designated for protection due to their exceptional natural beauty, wildlife and cultural heritage, whilst remaining a living, working landscape. And because of that, they include private land, farms and villages, and dedicated authorities managing conservation and tourism. There are 15 across the UK, and I'm going to focus on one of those for my next case study. And that one is the Bannau Brycheiniog National Park, which Forest Fawr UNESCO Global Geopark falls within in Wales. So the Forest Fawr UNESCO Global Geopark makes up around about half of the national park. So it is, by its definition, covered by the protection that the national park offers. The geological sites within the geopark are relevant to the natural beauty and landscape, and therefore part of the special qualities that define the national park. And they're also covered under the National Park Local Development Plan. And in conversation with some of the National Park Management Authority last week, one of the things they highlighted was whilst geopark status plays no statutory role in the protection of sites, it does place an expectation to be particularly mindful of geological heritage, meaning that more attention is paid to geoconservation than might be otherwise done. So if you like, it's again talking about that indirect conservation. And then my final area I just want to talk about with regards to indirect protection is the UK National Site Network. So prior to the UK's exit from the EU, these were known as Natura 2000 sites, which I'm sure all of you are familiar with. Regardless of our status within the EU, designation, protection and management standards have remained largely the same, thankfully. And the network is still a protected and high value conservation area. They're made up of special areas of conservation, or SACs, for habitats and species, and special protection areas, or SPAs, for birds, safeguarding rare wildlife across land and sea. None of those mention geological heritage. However, we all know that geological heritage underpins SACs in particular, but also SPAs. The picture on the right-hand side is from the Papastour SAC in Shetland UNESCO Global Geopark. which has been designated because of its sea caves, because of its cliffs, all of which are home to specific habitats and species, again underpinned by their geological heritage and therefore protected. My final case studies, however, are going to come from the Mourne Gullion Strand for the UNESCO Global Geopark in Northern Ireland. First and foremost, the entire geopark sits within 3 areas of outstanding natural beauty. So I've already mentioned those and the protection that an AONB offers. However, there's also a wealth of SACs, SPAs, and other designations within the geopark, all of which come together to help protect their internationally important geological heritage. The picture on the right-hand side is one of the activities done as part of peatland restoration. And whilst the peatland restoration is not directly the geological heritage, it does help to protect the underlying geology, including the Paleogene igneous bedrock that the area has been designated for and the glacially shaped uplands. The geopark itself has also got the Strangford Lough AONB there, which carries a host of designations for a whole range of reasons. It's a particularly interesting area because it's made up of part of one of the largest sea lochs in the UK, and the sea loch itself occupies a drowned drumlin landscape. This is really ecologically important, and it's only ecologically important as a direct result of its glacial geology. So whilst glacial geology is the foundation, it's the nature conservation, both at regional and national level, that does the protecting. But it's also that national and regional legislation that helps to provide the funding initiatives that then fund on-the-ground activities, and then through the geopark tie it all back to the underlying geodiversity. So this is all about using the tools that geoparks have, using the designations, by using that to access funding and then delivering the key activities that a geopark should be doing. So in my final slide, just to talk about geoparks and protecting their geological heritage sites. So fundamentally, they have to legally safeguard the internationally important geological sites. That is done through both national and by local legislation, and it's also done by managing and monitoring them through other designations that aren't specifically related to geoheritage. However, geological heritage is not just about the national legislation, about the legal protection. All of the work that goes on within geoparks, whether it be supporting scientific research, educating the public, getting local communities involved, promoting sustainable tourism, and linking our geology with our ecosystems and culture, they all help to protect our geological sites, albeit not legally. All of this combined helps to make these areas really well protected, whether it be directly, indirectly, legally, or otherwise. And I'm just going to leave it there. Okay, so again, if there's any questions, please put them into the chat. And with that, I'm going to hand over to Matevž for our final talk of the afternoon.
Okay, thank you very much. Can you see my screen now in the presentation mode? Is it okay?
Yes.
Yes,
yep.
I think it should be. Yeah, good afternoon, everybody. I will have, maybe it's a quite good continuation of the Kirstin talk, because I will not, maybe the title of my presentation is a little bit misleading, because I will not talk about protected areas and geoconservation in Slovenia in general. I will actually point out, in my opinion, a very good case of one of the natural monuments, which is in my opinion and several opinions of several geologists in Slovenia, is one of the most important geoheritage sites in Slovenia, besides of those that are already protected as I don't know, either under UNESCO designated or either even geoparks. So this is the case of the Dovžan Gorge, or Dovžanova Soteska in my language, natural monument, and it will show you for what I will showing you. So I will first give you some short presentation why this this heritage site was actually protected, what are the main the reasons for this, and you will see that it has all the qualities shown in the last Kirstin slide. So that is really very good. It has a very good qualities to be all the qualities that are required for the geoheritage designated sites. Also the scientific and educational important. And then I will skip to the Dojan Gorge as a laboratory for geohazard studies. So I will speak about a bit about relief and mass movement processes there and extreme weather events. And then I will go with the closing remarks on this, how difficult actually it is when it comes from this formal and very good written laws and protective initiatives when it really comes to the practical case. In how difficult can this be, especially when your geoheritage site is in the populated area, which of course requires other activities and other measures. So human activities and safety measures are influencing the protection of this geoheritage site. So I will speak shortly about remediation and safety measures, a little bit of historical record of this extreme weather event, and then human perception of geohazard and geohazard mitigation there, and then balancing conservation and human intervention in populated geoheritage sites. So I will lead you to my small country of Slovenia, which is the Alpine country, at least most of the part. It's also Adriatic. It has a little bit of Adriatic Sea. But the area that I will be speaking about is here in the Karavanke, on the lower slope of the Karavanke Mountains, which is the mountain range shared with Austria. It is like in Southern Alps geotectonic unit, and this site is one of the most important because it holds on a great paleontological record, and this is also one of the reasons that it was protected already in 1988. As a natural monument. It was protected as a natural monument of national importance, but this is only because we have this, as already Enrique pointed out, this legal binding conservation management, because so it's under administration of the national law, not by local laws. So and within our this legislation, we don't have the internationally important natural monuments. So there are the highest level is national importance. So it was protected because of mostly because of the geomorphological reasons. Exceptional geomorphology here, as you can see already here. So this is a deep gorge that is carved by the Tržiška Bistrica River here in the late Paleozoic rocks, mainly limestone, but also conglomerates. So it's a diverse rock composition. And this is like 2.5 kilometers long gorge, exposing one of the best and the best preserved late Paleozoic sequence of rocks in the Southern Alps. So here you can see on the right hand side that the whole area actually is under the Natura 2000 protection, but this red polygon is marking the natural monument boundaries. So these are some of the natural features which was first reason for the protection of this site. So you have these limestone pillars, and here is the narrowest part of the gorge with the nice road tunnel here carved in the pure rock, and this is from the other side, and so everything in this case here are the Permian, early Permian rocks. and this cascading waterfall, which was also the reason for the protection, with the large boulders of quartz conglomerate in the forming the snow. But I claim, and it is also kind of recognized between geologists in Slovenia, that the most geologically important phenomena that are really of international significance, and this is, I will show you through some slides, why do we claim this? It is for exceptional fossil richness in both abundance and diversity of fossils. So you can see here in this short 2.5 kilometers long road section, we have fossils of a variety of the groups, from brachiopod, corals, gastropods, also those more rare ones like trilobites, ammonoids, and even the very rare ones, especially in the Permian records, like conularids, which is on the upper right-hand side here. And the other reason is the long and rich history of paleontological research of all these fossils group, and one of the breakthrough was really already in the 1900. So this was the treatise on brachiopods, this important fossils group, made by this German or Prussian paleontologist Ernst Schelwin, who described in this treatise, he described 81 different taxa of brachiopods, and of those 22 were first described species. So in other words, so the Dorzhanova-Soteska gorge is the locus typicus for several holotypes of those species, not only brachiopods, but also some corals, some gastropods, and another fossil. But in my opinion, one of the most important features of this is this long, more or less continuous cross sections of late Paleozoic rocks in the southern Alps. You can see here, this is the road, and the cross section here, you can project it to this landscape image, more or less. It fits to the rocks that are exposed here. So, and you can see that it goes all from the upper Carboniferous here on the upper side of the valley and down to the middle Permian. But this is only in the very center of the protected areas. Otherwise, it continues also down to the town of Tržič, through the entire Triassic sequence. So it's really quite an important. And why do I claim this is the most important? Because it allows many different interpretations. So reconstruction of paleo environment, of course, if you have rocks and you study their relationships of those different rocks, you can actually reconstruct the paleo environment. For example, this is the late Carboniferous case that we had kind of a fen delta, continuing into this flat coastal ramp with different fossils, and then it's changed in the Permian, in the rimmed carbonate platform, with even more fossil groups there. And also it allows then for the reconstruction of paleogeographical setting, because when compared also to the Carnic Alps, which are orographic continuation of these Karavanke mountains, in both we have pretty much similar lithostratigraphic development, and most of these rocks are actually defined by the cyclic deposition. You can see such kind of example of one cycle here. This is for approximately 40 meters thick sequence, and it's of course the main reason for such a composition is the sea level changes in this area, and those sea level changes are related, of course, with the waxing and waning of the ice sheets on the Gondwana at that time. So we can reconstruct the whole basin here, of course, with the help of other section, but this one is the most complete one. And of course, it then allows reading of almost 40 million years of changing environment through this. We can, these are kind of for the interpretation of and popularization of geology or education. We did these sketches of the different environment, of the changing environment through this section of rocks. It even more gets important for the very pure scientific purposes, because it allows also for the detailed biostratigraphic zonation and reconstruction even of evolutionary trends of fusulinate foraminifera, which are very, very abundantly present in this section, and even phylogenetic lineages of some of the genera, for example here like in the case of Dexina. So it is really very important. So we have also evidences for the international interest in this area. These are just some of the dozens of papers and treatises, and mostly on different fossil groups, but also on the sedimentology of the area, on the this cyclic pattern that I showed you, and such things. And some recognitions are also given by the letting us organize or lead the field trips. One of the latest important ones was this. That was a part of the 19th International Congress on Carboniferous and Permian in Cologne, but one of the excursions went to the Carnic Alps and Karawanke Mountain, is especially visited also the Dojan Gorge. But also for the geoheritage protection. So this guide to the right, field guide, was published in the occurrence of the ProGeo meeting in I think it was 2007 in Slovenia. We have also quite good interpretation of geology here. We are performing a lot of education activities and popularization activities. Already in 1983, there was a Dojanova Soteska, or Dojan Gorge, was the main the central part of the Slovenian geological trail. It was opened here in here, and also we have a nice representation of geology in the area with these geological pillars, which was one of the first in Slovenia. Now we have already 33 of them, so they are growing like mushrooms now. Every student campus puts up such kind of geological column. And then we have also interpretation panels, of course, and booklets appointed, a small exhibition and interpretation center. So more or less everything that is related to the education here. And now I will skip to this second part, so the laboratory for the study of geohazard. So if we see this that I've already shown it before and explain why the reason for such a pattern of occurrences of rock, and if we just rotate it and project it to the profile, or here to the landscape in this picture, you can very clearly see this very nice example of the relationships between the lithology and the morphology, because of course the massive limestone and conglomerates are producing or composing these ridges and pinnacles that are standing out, and while the gullies are developed in this fine-grained clastic rocks like siltstones and sandstones. And this, of course, also influences the slope mass movement processes, and I will show you just a few of them here, because everything is moving in this kind of topography you can imagine. One is the Borova Pech rockfall. So you can see on the very left-hand side this kind of a small mountain, this whitish. It's sloping above the small hamlet here, and you can see that even around the houses there are these very large blocks that I've shown you before in the beginning in the river channel. So these are all the blocks that were falling down from this Borova Pech, the mountain to the left, to the valley, and people are still living in these houses, not regarding really the danger here. So we had a group here, the scientific group from the Serres Institute in Aix-en-Provence, who are dating the such kind of rock falls and actually exposure surfaces of the rock with cosmogenic nuclides. And we asked this old lady if we can sample the rock in front of her house, and she replied that she can actually give us the very detailed information where this rockfall occurs. So and still people are living here, although they even remember when this was happening. So it's really, for geologists, it's quite an a funny thing, or we question ourselves if how this is possible. And not only the danger comes from above, you can see these blocks around the houses that are almost big as half of the house, but also the ground is not stable, so there are landslides on these shales and on the floor, so everything is moving actually. And another big thing is in the, so this is the Dojan Gorge on the right photograph, and the red polygon is actually a kind quite a big landslide or debris flow. It has these mixed processes, and the houses you see to the very right hand side of the red polygon are those who are seen in the left. So the houses are already, the old houses are damaged, but the new house stands right besides this. And this the second picture is in somewhere in the middle of this gully that is kind of the conway of the most of the very obviously active mass slope movements here. But one of the most problematic is this beautiful river that in summertime or in nice weather, it's like a pleasant place, but it turns when it after the hard rains, it turns into this very, very dangerous torrential flow. And I will just expose now one of the extreme weather events that happened in 2018 in October, in one of the after very hard rain. It was during the night, and I will be showing pictures from the Jelendol. This is the small settlement above the Dojan Gorge, and the Dolina, which is the settlement inside the Dojan Gorge. So here you can see some images from Jelendol. So you can see that the river did not, the river course did not obey anymore its natural riverbed. So the debris was all over the place. But even worse was in the Dojan Gorge, because the river bed was totally eroded. 5 of the bridges were damaged. The road was heavily damaged or flooded with debris, water and debris. So it was really caused a great material damage. And the remediation and safety measures following this, because there were also some European funds designated for the restoration of this or remediation. So mostly all the slopes were then covered with this protective wire meshes and flexible rockfall protection barriers that they don't look very, very nice. And now You can even see still some of the outcrops, but as you are well aware, when you protect something with this wire mesh, it's very quickly overgrows with vegetation, and you can not see anything anymore. And this is also the case with the, for example, the type section of one of two of the formations in that were established here in Dojanowa Soteska, so lithostratigraphic formation. It is now totally covered with the wired mesh. The same goes with the locus typicus or the stratum typicum of the several foraminiferal species. So here in the picture is in the middle is the, maybe some of you know this important man. This is Franz Kahler, one of the important Austrian geologists, and maybe even more famous is the man to the left. This is Eric Fliegel, the famous author of the Bible for microfacial studies. They visited this area because Franz Kahler was the author of this beautiful fusulinid foraminifera, Schwagerina carniolica, that was described from this section. But this is now all covered in wired mesh. And the latest one also touched the river that was before protected, like no one can touch it. Always was this saying, no, because we were trying to put some passes along the river, and they claim this is not possible because the river should stay as it is in its normal. But then it came to this, so the river training almost along all the riverbed. And let me remind you again, this is the natural monument of the national importance, which is legally preserved as the that the national processes have to stay natural in such kind of monuments. But we had then this intervention instrument that, if there happens such kind of event that I shown you, that all this legislation can be overruled or neglected, and can be. So my question in the end, when all this happens, I was pretty devastated. I was asking them what has remained natural of this natural monument of national importance, and I will show you that I'm not exaggerating. Yeah, so this is also the total estimated cost of rehabilitation was like 12 million euros approximately. And that I'm not exaggerating, I can show you the image of the human intervention in this in the Dojan Gorge. So you can see that there is almost nothing that is preserved natural anymore here. And even more, it gets funny when you start to read historical record of such an event, and you can see that almost every 20 years or something like this happens, and we have a very good record because there was here was an important industrial facility here, because in the hinterland of the area it is a large woodland area, and the timber is transported through the Dojan Gorge massively. And there was also this mill saw in the past. So because of the damages to this facility, the record is very good already from the 1922 and following. So to the last point of mine is now I'm stressing the problem of balancing nature conservation, and you can claim, of course, now because of these wired meshes, it is actually the fossils are preserved better than any time before, because no one can touch it now. Nobody can even see anymore those fossils, and almost not the rocks exposure anymore. But so the balancing of nature conservation of safety measures in populated geoheritage sites it poses quite a challenge, I think. And I'm claiming now that how to what degree should we consider the priority of the inhabitants, because the population here is Dolina Helmet and Jelendol together not even 200 people. And of course, you have to also now take into account the data on the precipitation that indicates that at 6 extreme rainfall events classified as having a return period of 50 to 100 years have occurred over the only past 20 years. And with the cost that I presented before, this is really a question, what does it make sense? And the new event in August 2023 damaged most of the things that were restored after the 2018 event. You can see that. So in such kind of environment, in my opinion, it is almost impossible to protect, because everything is in the very short valley with only slope debris and the alluvial sediment. So in my conclusion, the question raised here are aid financing as a government responsibility, to what extent and for how much longer does it make sense? And then, of course, the climate change adaptation plans, national and European, at what point should action be taken? So that some people have to be moved from their areas because it's not safe or it's too costly to maintain this all the time. And then, of course, the conservation of geoheritage. How important or valuable does it have to be considered a priority? And I don't have any answers for this. Actually, this is more for the discussion in this our meeting today, or to consider this raised question in the future, because I'm sure that this is not the only case that you can find some relations in your countries. So do reasonable answers to above question actually exist about from those that are mostly grounded or subjective or emotional basis? And is there a model that can be used to evaluate these factors? So how, especially on the geoheritage protection? Thank you very much.
Thank you very much, Matevž. There's some very thought-provoking questions and some fantastic, albeit devastating images that you shared with us. I just wondered if anybody has any questions, because we have got time until 17:30 for some questions and answers from any of the speakers. Just a reminder, if you do want to ask a question, please use the raise hand function. And if you want to, please turn on your camera. And I see we have a first question from Claire Glanville. I also see, Claire, you've got a question in the chat as well. So Claire, please go ahead.
You go back to Army claims and please. It's the same question. Hopefully you can hear me, because I have somebody in the background on a call at the same time. So yeah, my question just was both from Enrique's presentation and from yours, Kirstin. I was wondering, Enrique, you spoke about the National Conservation Areas, part of the Natura 2000 network. Yeah. And you talked about them from geological heritage perspective. And I was just wondering, are those sites, do those sites in the Natura 2000, are they designated for geological conservation objectives, or just ecological conservation objectives, like the ones in the UK, where the geology is an indirect protection? Or are those sites specifically designated for geology? And if they are, then why did you decide to go with the SACs rather than the natural heritage areas?
Okay, no, when I was mentioning the Natura 2000, it's only about the overlapping of different legal frameworks. In that case, some areas have the geological heritage inventory in a protected area, but as I suppose that everybody who's listening already knows, our nature directive is not total nature, it's only biodiversity. It was based on the 1970-89 Birds Directive and the 1992 Habitats Directive, and that's it. So it's only biological heritage, species, habitats, and ecosystems, and that's it. And there's the only thing is that by luck, some of the sites that were protected with this European legislation coincide with geoheritage. That's the only issue. And in some cases, whoever is managing the area, they have included the geological heritage, but it's not because of the European legislation. It's usually because it is included in the management plans for whoever has done the inventories in the area, but it's very, very seldomly included. Normally, the justification for the Natura 2000 is species and habitats, and that's it. And of course, natural monuments, that the one that I showed, the only basis, for example, for this IUGS GSSP is the geology. So, but it is a natural monument, and normally all other legal protection of the territory should include, if it is a protected area for nature, for natural heritage, it should include geological heritage.
Thank you.
Actually, it is a pity. It is a pity that Sven Lundquist left, because he knows also about that. In the last decades, we have 15 years or so, we have been trying to influence with the IUCN in Brussels, and also with policies in the European Parliament to convince. I mean, we made a note through the EuroGeoSurveys, actually, that was because there's an agreement, an MOU, a memorandum of understanding between EuroGeoSurveys and ProGeo. Sven is part of the executive committee, is the treasurer of ProGeo, and we had this concept note submitted to the European Parliament regarding this issue, that it needs to be considered geological heritage as part of natural heritage, not just biodiversity, as it is called, so not only species and habitats, but also geological heritage. But still isn't. So it depends on what each country has in its own national legislation.
Thank you, Enrique. Yeah, I was asking because we are at a stage now in Ireland to select a number of sites to propose for natural heritage areas, NHAs, which we can do under our legislation, which specifically calls for geological heritage as part of natural heritage. But I was just wondering, because I also had a conversation with the National Parks and Wildlife, who look after our Natura 2000 network, about including geological objectives, conservation objectives, and they said no.
Yeah. I'll maybe try and get one or two more questions in, if that's okay. So Michael Dempster, if it's over to you, you've got your hand up.
Thanks, Kirstin. It was actually just to add to that answer from Enrique about geo features in SACs. If there is a supporting process for the SAC features, which is abiotic, then that's covered. Just as maybe an interesting point. So in something like a dune system, that free movement of sediment and deposition of sediment would be covered within the SAC conservation objectives. But yeah, I just wanted to kind of point that out, that there are some elements that are included, but not geological in the way that maybe you're thinking, Claire.
Yeah, that's a good point, because many times there's geological elements that are completely, fully conditioning the habitat. Like right now, we are doing a study in Spain with the carbonate tuffs associated with this 7220, the habitat with these mosses that are conditioning the precipitation of carbonate, and at the same time the carbonate buildups are conditioning the habitat and so on. So, and it's a full interrelationship, and it needs to be considered. But the pity is that it's only considered as a substrate, not as relevant by itself. So if there's which in many cases there are very nice carbonate buildups that are no longer full of mosses, then it's not included as important. It's only important because if it has the mosses. No? So only in relation with the actual the species of interest for the Natura 2000. So
thanks, Enrique. I think we are going to have to leave it there, Marina. It's
we can
17:32. Well, I think the time was up, isn't it, at 17:30? Is that right, Marina?
Yes, it was.
Yeah. So I'd just like to thank all of our speakers. I think it was a really interesting set of talks that really complemented each other in scale and in breadth. And thank you to all of you for attending as well. If you have any further questions that you want to ask, please do reach out to any of us, and we can definitely answer those. So thank you all once again, and I hope to see you all at the next webinar. So thank you all very much.